Please welcome to the stage Philip Shelley, CTO, Sears Holdings.
Okay, well, thank you for Jeff and Scott setting me up. Jeff, you set me up beautifully. First of all, I'm not sure if I crossed the chasm or all of you did, because I'm in a suit and tie and you're not. So I could be the early adopter, you never know. Times always come around in circles. So we've been, as Jeff said, we've been 40 years in modernizing IT systems. And for 20 years, I've heard the mainframe is dead, but long live the mainframe. I'm going to take you through some use cases, actually, which are mainframe-centric and how we use Hadoop to start offloading, finally, offloading mainframe workload. And by the way, this afternoon, Jeff and I will be doing classes on medieval bone fracture healing. And we'll even inflict pain on you to imagine what it's like having your fracture either created or healed without anesthetic. So that'll be in room whatever it is, I don't know. So anyway, first of all, thank you very much for the organizers for inviting me. And good morning, of course. So I think we're in the beginning of a very exciting and innovative journey. In my mind, where we are with Hadoop in a traditional enterprise, I'm going to focus on the traditional enterprise view of Hadoop. Where we are is just, in my career, I don't think I've ever seen such a fantastic opportunity or capability that's emerging now. So first of all, I'm a CTO from Sears. I'm also a CEO of a startup in the Hadoop space. You probably know Sears. All of you know something about Sears, but it's a $43 billion enterprise made up of many subsidiaries. It's mostly, of course, in history, more than 100 years old, a bricks and mortar retailer. Actually started as a mail order retailer, so it was sort of the precursor of what we do online now. You order on a catalog. But it's now going back again, of course, to be an online retailer, and we're now one of the largest mobile internet retailers. We are becoming the number one in some months of the year now, the number one mobile internet shopping destination. We run, in our legacy back-end systems, we run many hundreds of millions of jobs. We have more than 100 million lines of COBOL and assembler. If anybody knows mainframe assembler, then come and talk to me afterwards, because we do have to convert that to pig. And I'm not joking. So we have COBOL-focused JCL assembler that are written more than 30 years ago. So the mainframe really is alive. We run almost every enterprise system you can think of, almost every flavor of enterprise data warehouse, significant amount of ETL, many copies of data between those systems, which drives me crazy. I have a no ETL zone on any new systems that we do. We run just about every type of distributed system, from very old versions of AIX, Sun, HP Unix, sorry, HP, we just got rid of it finally after 2.5 years, Windows, even a couple of AS400s. We really do have a lot of modern systems as well, though. We have one of the largest private clouds. All of our new systems go into private cloud. It's an entirely open source stack based on Zen. And all of our new systems that we modernize, if they don't go into Hadoop, go into that. And finally, Hadoop. We built out Hadoop over the last 2.5 years to be a very strategic and important part of our landscape. We're doing things that it was previously impossible to do on a scale that we just couldn't imagine before, and I'm going to take you through 4 use cases today, which are very practical examples of how to run a legacy enterprise using Hadoop as a technology. So I'm going to give you an overview of that journey. I will cover the challenges of a large enterprise has today. Jeffrey touched on that today, and I'm going to come back to some of his points. But the importance of thinking about this as an ecosystem, end-to-end ecosystem, how do you integrate Hadoop into a real enterprise, and then, of course, the use cases. So I'm fortunate to speak to many CIOs and CTOs at different groups, and I commonly see that more than 75% of those people have no idea what Hadoop is. Most of them don't know how to spell it, and they certainly don't know what it is. About 10, 15% actually do know what it is, and some of them are dabbling in it. But in traditional enterprises, it is really low awareness, and we have to fix that as a community. But I'm really excited about the tremendous opportunities we have, and I'm so excited we're actually well underway in changing our company to be much more of a real-time digital enterprise using Hadoop. We can solve problems that really completely outstrip conventional technology, and we can put data in a single place and eliminate most of our ETL on new projects. Killing off ETL, in my mind, is one of the big opportunities in large enterprises, and using Hadoop to do that. Scott just mentioned that. And running a lot of batch work in a fraction of the time is really important. So we're all under this pressure of growing volumes of data is everywhere, not just on the internet companies, shortening process windows, costs cannot escalate. Our budgets are being capped or being reduced in many cases, and we have to eliminate this problem of ETL and latency in our data. So the phases we go through here are I'm going to take you through a few phases. Let me just change slides here because my slide thingy is out of sync down here. So when we look at reinventing things on enterprise-wide, we start to look, first of all, at an enterprise data architecture. I'm a big believer in designing an enterprise architecture that's scalable for the future, that is somewhat future-proofed, and gets us out of the trap of separate instances and separate databases that we've been in for decades. We need reliable, high-speed, reliable, near real-time solutions. We have a company like ours with hundreds of thousands of employees that we have to engage. We have to deliver things every day, every minute, every hour, and we have incredible amount of deliverables to do. So the key to us was to getting a data architecture that's solid and future-proof. We want to make Hadoop for those transactional systems the single point of truth. We really want to, say, massively reduce ETL. We need to retain the source data in place. Historically, we've never kept a lot of source data, individual point-of-sale transactions, individual clicks, individual scans of boxes in the supply chain. We didn't keep it because it was too large. But we really need to do that, to do predictive analysis and to serve customers better. Now we can do that on Hadoop. Now, the important thing is, and I was talking to some people just before the meeting, is to think about this as an ecosystem. Hadoop isn't the panacea to everything. It does not mean that you're going to use Hadoop and replace everything else. It's an ecosystem. You need to build real-time data ingestion, real-time use of that data on the back end. Hadoop won't do all of those things. We have to pull in data from our enterprise service bus. What's the role of enterprise data warehouses? They still have a role, and how do we integrate them? We fundamentally want to drastically reduce ETL. We want to consume data as near real-time as we can, and we want to use Hadoop for our transformations. So this is our architecture at a very high level that we use today. It's certainly Hadoop-centric for transactional systems, and we're feeding data. Most of our data is structured. There's some unstructured data, but most of our use of Hadoop today is structured data, is traditional structured data. We've greatly simplified the way we handle copies of data. So in Hadoop, we do have layers of transformation, but we consume the data in one place. We transform the data in one place wherever we can. We want to expose that single representative version of data, single point of truth, whether you like that term or not. We want to have that for consumption to avoid confusion. And we want to seamlessly integrate those systems with our enterprise data warehouses, graphical user interfaces. So before I go into the use cases, the learnings. So more than 2 years behind us on this modernization. We've had a lot of hours here. We've made mistakes. We've spent hours, days, weeks learning how to do this. Things that didn't work, correcting things that blew up, which we did, repair mistakes, but we've also seen some fantastic results. We've made a major positive impact. The use cases I'm going to show you made some major positive impact to those businesses that we serve. We've made some spectacular reductions in runtime from mainframe or enterprise data warehouses, and we do deep statistical analysis using R on Hadoop. We have massively deeper detail, much longer history than we could ever do before. And we can reliably meet our production schedules, even though we have constrained budgets and increasing amounts of data. So these facts are very, very common in many enterprises. If you're in traditional large enterprises, you'll see this over and over again. So let's go over some real examples. I have 4 real live examples that are in production every day at Sears Holdings companies. And we'll spend some time on each one to explain why we did it. So for any retailer, I have two examples on pricing here. Any retailer, of course, pricing, you are all consumers, we're all consumers. Everybody is sensitive about price. You set the price too high, and then your sales are too low. Set the price too low, your margins are squeezed. We run out of inventory. We waste marketing time and marketing spend. And also, we disappoint customers. Believe it or not, if your prices are too low, you can end up disappointing customers more than if your prices are too high, because people want it and they can't get it. So the term price elasticity may be known to you, but price elasticity is the technique of understanding the correlation between price and how well things sell. So there's many factors that affect price elasticity. It's competitors, of course, other retailers, innovation in the market. Things like the weather, the general economy, product availability, sentiment analysis, all affect the propensity for somebody to buy something at a certain price. Retailers have known this for a long time. It's been very difficult, though, to do this type of analysis in near real time. So the exact algorithms, how we do this, are proprietary, so I'm not going to disclose those. But what I will say is by studying enough historical history of price, inventory, and all the other factors I mentioned, you can actually become pretty accurate at calculating price elasticity of where you are compared to competitors and make a big difference to the margins and also the sales of the company. So we historically ran price elasticity calculations on our large enterprise data warehouse. But even there, with a subset of data, not all of the data, as you see here, we have large amounts of data coming in. We could only do subsets of data, and we still could not finish it on time. It took about 8 weeks end to end to run that entire process, to do a price elasticity run. A lot of that was runtime, some of it was ETL, but it was about an 8-week process on about 10% of the data. So we wanted to go to 100% of the data. Clearly, that was going to be a challenge. So what we did here is by running the algorithms on R in Hadoop. We actually coded the Hadoop jobs in Ruby, MapReduce. We now run 100% of the job. There's 10 times more data. And now we run that much faster and meet the SLAs. So we got 100% of the data we can now run weekly if we want to, and some of these things are actually running daily. And believe it or not, on the next example I'm going to show you, we're actually running it now multiple times a day for some people. People want personalized pricing, personalized offers. I think Jeffrey touched on that. We all want personalized experiences, and now we can do that. We can calculate on incredible levels of detail right down to the individual consumer, the individual product, and do it multiple times a day. That was absolutely impossible with any technology we had before. The next one is also a pricing one. Prices are also time-bound, of course. As I mentioned, the seasonal changes, product purchases, clearances. We have to compensate for inventory levels. No retailer wants to be left with $100 million of obsolete inventory. Retailers have to quickly react to competitors, marketing campaigns from competitors, marketing campaigns from us for a reason. A weather storm could be coming in. We want to make sure everybody knows we have snow blowers available in certain stores and send you a personalized offer if you're a loyal customer to that. Retailers have to react very quickly. This fast-moving digital experience for retailers now is forcing. We do not want to be Amazoned. We want to. I'll have to think of a verb to Sears somebody else. I'll have to think of that. There's probably a word somebody's going to think of in the meeting. We want to adapt very fast in the retail world now. It was the case, of course, that years ago you'd have national pricing for products. And then a while ago, we went to regional pricing for products. And for a large retailer with us, with millions and millions of products, 4,000 stores, well over 100 million customers that we know detail about, we have just too much data to even consider regional pricing as being valid anymore. You all see that Amazon is doing that now too with regional and local pricing. We do the same. It's becoming absolutely paramount for a large retailer to do that, right down to a granular level of detail. The businesses wanted to now set prices multiple times a day, not just nationally, but they want to do multiple times a day at a store level for all items down to the individual customer. So we want to send, and we do not want to, we do send, if you're a loyalty customer, individual coupons that are calculated just for you based on where you live, how many products we have in the store, of the products we think you like, how much we want to get rid of in that store, and make you a custom offer. Now we do that multiple times a day, and some of it we're actually doing is real-time offers by looking at basket analysis online or at the register as you're checking out to do real-time offers to you based on what we know about. The real-time bit is not done in Hadoop. It's done in a separate system, but then all the rest is done in Hadoop. So we have to process now billions of rows of data with hundreds of billions of combinations, and we have to do it multiple times a day. So that's a very good example, I think, of another pricing example. So the way we did that is we moved the source data from Teradata and Mainframe onto Hadoop. We implemented all the processing in Pig. There's quite complex financial calculations in this one. So we did use some UDFs written in Java. The project was very fast, though. It only took 6 weeks to do this project. We meet all the SLAs. We're saving more than $500,000 a year by not consuming mainframe MIPS and reducing our costs there. And the big thing for the developers is it went from 6,000 lines of COBOL to about 400 lines of Pig. So they love it from a development and a maintainability point of view. So we're now getting real advocates that were mainframe COBOL developers now enjoying Pig development. I told you I wasn't kidding. Number 3 is just another example. It's a non-specific example of where we just ran out of capacity on the mainframe and we had to do something. You know, if any of you are mainframe people, many of you are or were, you know there's pretty tight schedules we have to hit. There's batch windows we have to hit. If we miss a batch window, it cascades all the way down and everything starts to fall apart for the whole day. And nobody wants to be, I certainly don't want my name in front of the CEO and chairman every day because we've missed our batch windows. But we were starting to do that on this particular example. We don't want to add mainframe MIPS. I absolutely want to take them out. I don't want to add them. So that is not an option. The overall cost for running a MIP on a mainframe, I'm not sure if any of you have ever calculated that, but typically in the industry it's $3,000 to $5,000, maybe $7,000 per MIP per year. So you can do the math when one standard server nowadays in the modern distributed servers will do maybe 400 or 500 MIPS of workload. $5,000 per MIP per year is an astronomically expensive solution. So we have to move off that. Batch windows aren't going to move. We have to get the work done. And with one, we had a 3.5-hour batch window, and it was impossible to do. 64 jobs, many thousands of lines of COBOL, 500 million rows of data. So the solution, again, was to move the batch processing from mainframe. But this is the reason I'm using this example is it's a very interesting way of offloading traditional legacy batch processing. We didn't change the application on the mainframe. We didn't change the source data. It still goes into the mainframe, but then we move it onto Hadoop for the batch process itself. So data still feeds the mainframe. And we developed the technique of offloading just the batch piece, but putting the results back on the mainframe again. So the sequence here is the mainframe ingests the data just like it would. We FTP the data to Hadoop. We run the batch job on Hadoop. We FTP the results back to the mainframe. Believe it or not, none of the applications change, and we meet our SLA quite easily. So in this case, the whole job ran 100% faster. That is a sort of masking the truth because that 3.5-hour batch window on the mainframe, the actual batch now runs in 8 minutes on the Hadoop. The rest is all FTP time. So if anybody knows how to do faster FTP, I'm all ears. Because this technique is a fantastic way of offloading MIPS off the mainframe, but not changing your core applications. And we think it's going to be used a lot more. The final use case is really a user experience one, and this is another twist on using Hadoop to really improve user experience. One of our business groups uses business objects running against our enterprise data warehouse. It's an interactive use case, but there's also some batch to prepare some of the work. We have very large interactive and batch queries on our data warehouse that were frequently running too long on the batch and also too long on the interactive for the users to be satisfied. They also wanted the batch and the interactive to produce Excel outputs that, whether we liked it or not, many of us use Excel. And so that was a criteria. So the solution here was to source the transactional data and other data that we wanted into Hadoop, but retain all of the history in Hadoop. We want to keep our history of source data in Hadoop forever, so we can always use it for reuse and for long-term trend analysis. So that's really important for us to keep that history. Hadoop allows us to do that cost effectively. We wanted to add extra granularity. The business wanted extra granularity in this data that they didn't have before. We brought over 50 sources of data every day now into Hadoop that were previously going into Mainframe and Teradata. All the jobs were the batch jobs were written in Pig again to transform the source data and establish what we use as a single source of truth for that transformed data. And then we give user access using Datamere directly to Hadoop. So the users now run their interactive queries through Datamere directly on the Hadoop cluster. As well as the batch jobs running in Pig produce Excel outputs for people. So Hadoop does two things here. It does the Excel batch work, and it does the interactive user experience using Datamere as the interface. So performance isn't an issue now, storage isn't an issue, and we can keep much more detail and granularity in the data. So in summary, after extensive learning curve for multiple years here now, developing tools that interface Hadoop into a large and complex traditional company. This is for structured data, almost entirely structured traditional data, which people often criticize or don't understand Hadoop can be used for. We have a solid evidence for running these very complex and big batch jobs in a large company. Significant cost reductions, much better performance. Processing has been offloaded from legacy systems, much more reliably meets schedules. We've created really new and valuable business capabilities. But it's always part of an ecosystem. It's not just a Hadoop. There's always other things around it. There's other tools, and it has to be part of an overall enterprise data architecture. But don't underestimate the effort. The effort is significant, especially skill development, change management. It's a big effort. So the Hadoop community needs to work on a few things in the future. We all know the foundation is really strong that you've built today. Tools, though, to integrate Hadoop into the enterprise are still pretty crude. We've written some. We still need more. Education is really key. We need more reusable components, though. The community has done a fantastic job, a spectacular job of making this happen to date. I really want to personally thank the community, a lot of you are here, for developing this amazing technology that we're all starting to use. I know you've worked tirelessly to do that. I have deep respect for what you've done, and I'm really appreciative. But we have a lot to do on this journey together. So if you want to contact us afterwards, we have formed a subsidiary called MetaScale, actually, to help others who want to do integration of Hadoop into an enterprise. So now there's a new company under the Sears holding umbrella called MetaScale. You can contact us if you have questions of what I've just talked about. You want to understand more about the use cases. But I'm a firm believer that this is the beginning. We're definitely on the early adopter side, but it is the beginning of a whole new thing. Thank you.